Okay, again, we do a quick recap. These are the skills we have, right? We were doing equation of circle. We mentioned there are two ways to write equation of circle. One is the standard form, which is in the first video. Now I'm going to teach you about the general form, which is the second way of writing. We kind of touched on it the last time. But before we do that, let's recap one more time. To form the equation of circle, there are two pieces of information we need before we can form. Do you still remember what are they? Anyone? Leonard, what do we need to know before we can form equation of circle? Center of the circle, coordinate of the center of the circle, and radius, right? So vice versa. If we know an equation, we must also know how to read off the center and read off the radius. That is something that quite sure that will be asked. Okay, so we started the chapter by talking about standard form, which is to write things in this way, right? Once we know the center and the radius, we can form in the standard form. Make sure that the radius is squared. Example 5 square, you must square it already to show 25 as the final answer. If not, if you leave it as 5 square, it is deemed as incomplete. Okay, then we went on to try to find circle. We use these other formulas that we mentioned here, right? Midpoint, gradient, length of line segment. We've gone through this many times. So today, we're going to continue and talk about the general form. Now, the general form of the circle's equation is obtained by actually expanding the standard form. Right? We expand the equation from standard form over here using your algebra, the algebraic identity, right? The a squared minus 2ab plus b squared. Use that to expand, we will get to this format. Okay? So let's quickly do some practice. Okay? And we try to make use of the general form to find the same two things, right? To find the center and also the radius, right? Now, there are generally two ways that people will use to solve this. How? Number one, they use the formula here. I think Crunchy usually uses this method. But it can be a little bit confusing. We have touched a little bit on how to use it. So what happened is that first thing first, we need to ensure that the coefficient in front of the x squared and y squared must be positive 1 only. No other way about it. Once it is not positive 1, it may not be a circle anymore. It most likely is an oval shape or some ellipse. Second thing, we look at the coefficient here. Right, the coefficient for the x and the coefficient for the y. That is, these are the numbers that are critical for us to get the coordinates of the center. How do we get that then? So basically, they say, hey, if this is called 2g and if this is called 2f, then center is minus g and minus f. That is really difficult for people to remember. So what do? I always tell my student, don't think too much. Just divide that number by negative 2. Example, practice sound 16, I'm going to use it as an example. I see that the coefficient for x squared and y squared, they are positive 1. Everything is in place. Everything is arranged to one side, right? The other side is 0. What do you want again, Alex? I don't want you to disturb the class. What are you all doing with him? Can you all focus on my lesson instead? Okay, so what we do is I see that the coefficient here is a minus 6. I will divide by minus 2, right? To get the center's x coordinate. Positive 8. Divide by minus 2. Okay, very quickly that will arrive at the answer 3, negative 4, right? That is your center of the circle. Quite straightforward. So far so good. Okay, next one. How do I get the radius? This one a bit troublesome. Then is the what? You see, center is minus g minus f. Then radius is g squared plus f squared minus c. What? That sounds quite bad, right? It's like so messy, so confusing. So how I remember is this way. Whatever the answer here, I will flip the sign. It was a 3 for the center's x coordinate. So I'll write minus 3 bracket square. When it's a minus 4, I will flip the sign also, become 4. So basically, you will flip the sign. Whatever the center's coordinate, you flip the sign. And then you square it. But Mr. Lim, actually, if I square, wouldn't everything just be positive anyway? Right? I don't care if it's minus 3 square or 3 square. Isn't it still positive? Well, yes, you are right. So sometimes, right, some of my students who forgot the formula, they just wrote this straight away. They don't want to let people know that they don't know it's 3 or minus 3. So they just write 9. You know what I'm saying? Okay? Yeah, I think you can get a mark still. Now the thing is, now if you want to remember it properly and sum it properly, it's always the opposite sign from the center, okay? And then what is minus C? Now what is C? C is this number, including the sign. No, it's not. It's not. Don't say it's not 1 intercept. This is circle, different from line. Okay? The 9 here is the C value that we use. But C we don't. C we don't switch the sign. I mean we minus whatever C value there. So let me show you one more time. This is a plus 9 here, right? So I will minus, it's a minus a C. So minus a 9 lah.
But why for G and F?
It's just a formula. The formula says switch the sign. Yeah. That is if you use the formula. Are you so far okay with the idea? So what is confusing is the sign. Minus G, minus F. What? G square, F square? It's like it's going to confuse people and cause you all to make careless mistakes. So do take note. Okay? Now, I'm going to show you here again one more time. Now, before I continue, I'm going to ask if anyone is lost. If we use the formula. Okay, next thing. Now, what if I don't want to use the formula? I find it so troublesome. Then, another group of people, which a lot, I think I can say that a lot of good schools, they prefer the next method that I'm going to say. They're going to try to change the general form back into the standard form. Because standard form easy to read. But the process of changing the general form back to standard form can be quite tedious. So remember, how did we say that we get from standard form to general form? We expand, right? But if we want to revert this back, right, to this form, right, what do? We complete the square. Wow, so happy, right? Okay, I will not enforce that on you, but there are really students who prefer complete the square. But I don't belong to that category. But I can say that some schools, right, they will insist on completing the square as the method to do. Okay, so let me show you how to complete. We started the year with complete the square. So the same practice now, 16 question, 16A. I'm going to solve the same question using complete the square. How? We group the x and the x square and the x together. We group the y square and the y together. So far okay? Then we do complete the square for the yellow part, the x. Remember, we always look at the coefficient here, divide by 2, right? That's why we have x minus 3 bracket square. Then this one is always a minus. Can? So minus what? Minus 3 square. Minus this guy square. So it's a minus 9. Any problem so far? Next, I'm going to move on to the blue color part. We look at this 8, right? Divide by 2 is a 4. Then this is a minus a 4 square. Anyone lost? It's always a minus, like I said earlier on. Then once you're done with that, you realize that you can just rearrange things, put all those numbers together, put this, and this together, and you realize that you are in a very comfortable position. Your 16 can be shifted to minus 16 can be shifted over, and now you got yourself in the standard form.
And square root 16 is the radius.
Yes, and square root 16 is your radius.
So easy. You get both of them at the same time.
Yeah, But the process of doing complete the square can be considered difficult for some students. So they don't like it. Okay? No, I leave it to you. If you see formula, actually it's still shorter. Side by side. Can I ask who will prefer to do complete the square? 1, 2, 3, okay, 4. How about the rest? Can I say formula? If you're going to memorize formula, you have to memorize it. It's not given. Not given. Can I next ask you to try practice now 16 question B. Remember what is the number one criteria? To make sure that the x square and y square has a coefficient of positive 1 only. Can you try to do first? Can you try to do work? How about I challenge you to do both methods? Just for one experience. Then you decide for yourself what works. I mean, it's obvious for me what works for me lah, but I want you to experience that. Can you do the formula method and also the complete the square method for the same question? Convince yourself what works for you. You didn't even try to do. Yeah, I don't want mental sum. I need to learn how to present. You are not doing it. What makes you think you're going to get it right at the exam? You're not presenting anything. Gentlemen, are you all doing work?
Yeah, got it correct.
Leonard, don't disturb. I can tell you, right, that no matter what you feel, right, there will always be two camp of people who, one would still think that it's better off like Leonard, complete the square is easy. I can get two answers at the same time. But there will be people saying, but formula is way shorter, what? Why do you want to do that? So there will always be two camps of people. Now, when they ask you for the center and the radius, usually it is worth 3 marks already. Okay? 3 marks. Yeah. Getting the center and the radius. The what? Doesn't matter, it's just coincidental. Don't have to think too much into it. Anyone needs help? I'm going to explain. Using method 1, using the formula, we say that we have to first of all always make sure equation of circle, the coefficient of x squared and y squared must be positive 1 only. But this is a 2. So what can I do? I will just by brute force, right? Get rid of the 2. How? Divide away, right? Divide away by 2. So I divide the whole equation throughout by 2. Once I do that, Then I can begin finding my center. My coefficient now is for x is plus 2, for y is negative 1.5. To find the center, I will have to divide both by negative 2, right? Okay? Please show me the working. Please do not just state the answer like that. Don't. I need to see the working. Do not bypass everything, okay? You show me at least this working and this working. Then, once you got the center, we are good to start. Remember, the formula for radius, right? Whatever the coordinates of the center, we flip the sign, right, to put inside the bracket. Then we square.
Wait, but if the C is already a negative, then the bottom you put a plus.
Yes. Because negative become positive. Okay? And our C value is 1, right? So it's a minus C, so minus 1. Answer is 3/4. If you want to leave at 0.75, it's fine. Remember to write units. Units. Don't just 3/4 or 0.75. Write 0.75 units. Those who are going to do complete the square, the same rule apply. Remember, complete the square can only be done when the coefficient for x squared and y squared also when it's also positive 1, right? Or negative 1. Okay? Remember at the beginning of the year, we learned how to do complete the square. It must be positive 1 or negative 1 to start. Sorry, actually it's just positive 1 to start. If it's negative 1, you got to factorize. My bad. Okay, I repeat. So to do complete the square, the coefficient for x squared and y squared must be positive 1 also. And we're going to divide by 2 to create that scenario. Then we group the x squared and x together, group the y and the y squared together, and then we complete the square, right? And collate all those constants together, bring it to the right and square root. Any problem with this? I mean, looking at the working, there's no doubt that I would choose the formula because I'm lazy. Okay? But I leave it to you. Both are acceptable. So remember, general form and standard form, they are the same thing. They both can be used to describe the equation of a circle. How do you toggle and switch between them? Well, if you expand and rainbow the standard form, you will end up getting the general form. But if you go and complete the square for the general form, you go back to standard form. But they are the same thing, written in different formats. Are you good with this so far? I would like to move on. Alright, we're going to go through one example here. Okay? Find the equation of the circle. Hello people, can I get you to focus back here first? Find the equation of a circle which passes through point A and point B. Has its center line on this side. I feel that this is an important question I want to discuss. I'd like you all to focus on this because sorry, there are people talking. I don't want to call out names, but you're not listening when I'm telling you it is important and you still don't want to listen. Now, this is a very popular exam style question. You need to know. And unfortunately, because our school, we have not taught you the LIM-itlessMath version of the properties of circle, that's why you may have difficulty. So I'm going to quickly recap. I mean, not recap, probably just to highlight that part of the learning to you first before we solve this question. Okay? I need to open up circle. Give me a moment, please. Go. Now, I want to show you one of the property now. Previously, I told you that this property, tangent perpendicular to radius, is a very popular property when we saw, right? We say that when we have a tangent like this, a radius drawn here that touches the contact point, the same contact point, it will be 90 degrees, okay? That was called tangent perpendicular to radius. Today, we want to bring you to yet another property. Now, this is critical in today's discussion. Please listen. I repeat. Joshua, I need you to listen. Can you close the PLD? Because no need. No need lah, no need. No need PLD. I'm explaining on the screen. No need PLD. I want to talk about this property, perpendicular bisector of chord. Very nice pattern, important thing. There are three things covered. It's a very special property. I will show you here. This property talks about three things. Number one, perpendicular line, 90 degrees. Now, A and B are 2 points on the circumference of the circle. Any 2 points on the circumference of the circle, if they join together, we have something called a chord. C-H-O-R-D is a chord. Okay? 2 points that looks like A, the line AB is called a chord. The longest possible chord, of course, will be a diameter lah. Okay? But in this case, we are talking about the chord AB. Now, the three things we talk about. We have a line called OM. It must pass through center of the circle. Number one, right? Number two, the line OM and AB will form 90 degrees. And number three, the line OM will cut it into equal halves.
Sure. So is OAB isosceles triangle?
Yes, it is, but that's not the point of discussion. We are not interested in that. Yes, it is. Okay, so what is interesting about this property is this. Once two out of the three things are confirmed, the third is implied and assumed to be correct also. Example, if I say I got a line here, right, that is cut, that is bisect by another line. Like let's say I say OM cuts it into two equal halves. So cut into equal half, right? Bisect, right? Hang on. Use another. Bisect. Let's say I say OM bisect AB. And it's perpendicular, right? Because perpendicular bisector, that means it's perpendicular to it, right? If the question say OM is a perpendicular bisector of AB, that means it satisfies two things already. Perpendicular plus it bisect. Then I can confirm and I can assume very surely that OM must pass through center of circle. Assume. I repeat one more time. If the question tell you the line OM is a perpendicular bisector of AB, I can assume that it will pass through center of circle. Okay? That means two conditions out of the three conditions satisfied. The third condition can be assumed to be correct. Are you with me so far? Let's give you another configuration. Let's try. Let's say I say that, okay, I have a line OM that passes through the center and is perpendicular to AB. Then I can assume that it will cut it into equal half. You know what I'm saying? As long as two out of three are told to you, are confirmed, you can assume the third thing is correct. This is a very important strategy. Are you all with me or not? Concuss already, right? Okay, so this is an important property. So I'm going to come back to the example now. Okay, what example 17? Hi, Curious, I'm Mr. Lim. Nice to meet you. You're wondering again now? So
if they draw four chords and then they form a square in the center, then they ask you find the area of that.
okay, sorry, I don't want to be distracted with that first. We can discuss offline. I want to continue my lesson. Let me discuss what I want to discuss with the class first. Now, unfortunately, they brought up polya again, right? I don't want to use Polya problem solving method. I'm going to go straight to the point with you. Now, I want to talk about why I talked about the property just now. They gave you see, the question actually didn't draw you a diagram. So you may not be able to visualize. For the first time doing this, I think the diagram helps. So let's use a diagram. Let's see. Let's analyze the statement. Please follow my discussion because it's important. You find the equation of the circle means you what? You need center, you need radius, right? And the circle passes through 2 points. What do you mean by saying passes through 2 points? Listen up, it means that it's on the circumference of the circle. It passed through it, right? That means the points are on the circumference of the circle. Anyone lost? If not, you're not passing through it, Agree? Okay, so now, next thing. And it has the center of the circle lies on this line. So they drew a line with the see? The center of the circle is on this line. But where is it? Is it here? Is it here? Is it here? I don't know. I only know it's on this line. So far, okay? So now, we're going to continue. How do we start? Straight away, whenever you see such a question, a lot of people don't know how to do already. Because they cannot use the property of circle that we mentioned. First thing first. If these two join together, they form the perpendicular bisector of a chord. Agree?
Yes.
A chord. If you draw a perpendicular bisector like that, it forms the perpendicular bisector of this chord. Let's try again. We join AB together. It's a chord, right? Based on the property that I just introduced to you, I have a chord. If I have a line that bisects this chord, then what will happen? I can assume that the bisector of this chord, right, will pass through the center of the circle. So I'm going to make use of that. I don't know where is C. I know that if I can find the blue line, the blue line will also pass through the center of the circle. Since if I can find the equation of the blue line, and I'm given the equation of this purple line, simultaneous equation, I will get the center of the circle. I tell you the idea first. Anyone lost? Important leh. Do I need to repeat? Joshua, you explain. Never pay attention, right? I'm going to ask somebody else to explain. Leonard, explain. What am I doing? Don't know, right? You think? Explain this lah. What did I just explain? How to do this? Don't know, right? With what? So not paying attention. Very good. Talk a lot but cannot listen. Are you serious? You don't know, right? You seriously don't know, right? I'm going to repeat one more time. So many of you didn't get it. Now, to know the equation of the circle, we know that we need to find the center and the radius of the circle. Agree? But my problem is I don't know the center. I only know the center is lying somewhere on this purple line. That's all. That was what was told to me in the question. But there can be so many positions. How would I know where is it? So let's think of a way, right? So the important clue in such a question is always using the 2 points that were given. When they say that the circle passes through these 2 points, indirectly they are telling you, hey, these 2 points are on the circumference of the circle. And if I join these 2 points together, it will form a chord. Right? A chord. And we just learned earlier on the property of the circle. Any perpendicular bisector of the chord must pass through the center of the circle. You see, if it's a perpendicular bisector, it must pass through the circle center. So once 2 of the 3 is confirmed, the third can be assumed, remember? So in this case, the idea is, okay, can I find the gradient of AB? I can, right? Can I find the midpoint of AB? I can, right? So maybe I can find the perpendicular bisector of AB. Can I try to find the equation of the blue line? Do you know how? I can find gradient of AB. flip the number, flip the sign, I will know the gradient of the blue line. Then I use the midpoint of AB, right? I will have a pair of coordinates to sub in to find equation of the blue line. Once I get equation of blue line, based on what we learned here, since it's a perpendicular bisector of a chord, I know this blue line must also pass through center of circle. Given by the question, purple line also pass through center of circle. That means the blue line and the purple line must meet at the center lah. The intersection point must be the center of circle lah. I know my drawing is not perfect.
So do you do simultaneous equation?
That's what I said. Thanks for repeating me what I said, right? Simultaneous equation to get the center. Who doesn't understand this? Seriously, who doesn't? I'm going to leave it here. Remind me to go through the next one with you. Okay. This is an important example. Can you at least go and read out first? Okay, the next lesson I'll go through with you.